이상하게 생각해도 어쩔 수 없어 버렸으니까 You mama shake it shake it 지기 싫어 You mama shake it shake it 다음처럼 안 기다려 내가 말라 반해버렸다고 네가 맘에 든다고 하루 종일 보고 싶다고 Would you be my love 반해버렸으니까
Oke, Assalamualaikum warahmatullahi wabarakatuh. Annyeonghaseyo. Today we will learn about derivative of trigonometric function. Let's see here. The first in here we must know the derivative of sine and cosine. The first derivative of sinus x is equal to cosine x. And the first derivative of cosine x is equal to minus sine x. So let's see the proof. This is proof about derivative of sine function. And in here, of course you know the proof using the definition of derivative. F prime x is equal to limit h approaches to 0 from the function fx plus h minus fx over h is equal to the limit h approaches to 0 and change the function in here with using the sinus and sinus. So we can get the sinus x plus h minus sinus x over h. And then we can get f prime x is equal to the limit h approaches to 0 and then sinus x plus h is equal to sinus x times cos h plus cos x times sinus h minus sinus x over h. And then we can change approach to 0 with sinus x times cos h minus sinus x over h plus cos x times sinus h over h. So we can get the form sinus x open bracket cos h minus 1 over h close bracket plus cos x over bracket sinus h over h. And then we can get a limit h approaches to 0 sinus x limit of cos h minus 1 over h plus the limit of cos h and the limit of sinus h over h. And remember here, if we have the limit h approach to 0 from the function sinus h over h is equal to 1. And if we know that the limit h approach to 0 from the function cos h minus 1 over h is equal to 0. So the first derivative is sinus x times 0 plus cos x times 1 is equal to cos x. So it is proved that the first derivative of sinus x is equal to cosine x. Let's see the example. Find the derivative of the function fx is equal to exponent power x over cos x. So the first derivative is using quotient power x is exponent power x times cos x, and then exponent power x is the same, and the first derivative of cos x is equal to minus sin x. So we can get the new form. And we can simplify the exponent power x and exponent power x here and take in front of the function close bracket and open bracket cos x plus sinus x close bracket over cos x squared. So this is the result. Okay, for the next is chain rule for sine and cosine. We can see here if we have the sinus fx, so the first derivative is cos fx times the derivative of fx, and if we have the cosine fx is equal to sinus minus sinus fx times f prime x. Let's see the example. Find the derivative of the function f(x) is equal to sinus exponent power x minus cos ln x with the power of 100. So in here, by using the definition of the derivative, we can get 100 here, take here, and the function is the same, and the power must minus by 1. So we can get 99 in here, and then times with the derivative of this function. The derivative in here is the sinus is cos fx. So cos exponent power x and times to the f prime x. F prime x in here is same exponent power x. And then we can see in here cos ln x. The first derivative of cos is minus sin. So in here we can get the positive. And then ln x is same and f prime x. F prime x. Here we know that the ln x. The first derivative of ln x is 1 over x. So we can get this function. Okay, not only that, not only sin or not only cos, but we have the derivative of other trigonometric function like tangent, cotangent, secant x, and cosecant x. Tangent fx, cotangent fx, secant fx, and cosecant fx. So you must remember and understand about derivative of the other trigonometric function. Okay, you can see here. Let's go for example. Find the derivative of the function fx is equal to secant x over 1 plus tangent. By using the quotient rule, we can get the derivative of secant x is secant x tangent x times 1 plus tangent x minus secant x times the first derivative of 1 plus tangent x is equal to secant x squared over 1 plus tangent x squared. And then we can simplify that. Secant x here and the secant x here we can take in front of the function, and tangent x times 1 and tangent x times tangent x is tangent x squared minus secant x squared in here. So we can get the secant x open bracket tangent x, and then tangent square x minus secant x squared is equal to minus 1 over 1 plus tangent x squared. So in here's the first derivative of the secant x over 1 plus tangent x. So I hope you understand about the explanation.